This episode is sponsored by Menukora Honey. There are a lot of creepy creatures in this world, and the Microcosmos is no place to escape them. For every adorable tardigrade waving its stubby legs around, there are also countless nightmarish organisms lurking. And perhaps one of the most unsettling creatures to us here on our journey to the Microcosmos is the MITE. It's not enough for these tiny arachnids to remind us of every nightmare we've ever had involving spiders. These organisms also produce different compounds that manage to be unsettling in their own unique way. So today, we are going to revisit some of our previous videos about mites, following along through the varied lives different species live and the, let's just call them gifts, that they leave along the way. And we'll start out with the mites that might be sharing a room with you right now. One of the most frequent questions we get asked on Journey to the Microcosmos is how James, our master of microscopes, stays safe while gathering and studying samples. After all, as beautiful as the microcosmos is, there are plenty of parasites and pathogens in there that we'd prefer to keep under the microscope and out of our bodies. But while James has simple and effective guidelines to protect his health, like making sure he always washes his hands before and after handling samples and never venturing into a pond with an open wound, there are times when those measures don't quite cut it. These are the times when, no matter how much you protect yourself outside or inside, the microcosmos gets the best of you. These are the times of the dust mite. Now, we don't usually start these videos with a warning, but we're going to do that today. While working on this video, at least 4 members of the Journey to the Microcosmos team found themselves having a bit of a crisis about how clean their homes were. If you found yourself sneezing and wheezing and running around miserable with a runny nose because of dust, this arachnid is probably the culprit, though perhaps not in the way you would expect. Dust mites are small in the grand scheme of things, but large in the microcosmos, hitting just around 300 micrometers in length. Their bodies are decked out with 4 pairs of legs, ending in feet that act like suction cups as they wander in their quest for 3 things: water, food, and darkness. Dust mites love humidity because their lives depend on it. They don't drink water so much as they osmosis it into them, relying on a salt-filled gland near their mouth to absorb water vapor from the air around them. So if their surroundings become more arid, an adult dust mite will wither away until it eventually dies. This is a challenge for dust mites that live in places with seasons, where wet and rainy falls give way to dry winters. To survive those shifts, they rely on the resilience of their younger brethren, the nymphs, whose forms are able to withstand that lack of moisture. The seasons of the dust mite's life was one of the important clues that helped scientists in the 20th century understand their role in dust allergies. Scientists identified dust as the source of some kind of allergen in the 1920s, but they were not sure what it was exactly about dust that did it. They just knew that people all over the globe suffered from dust allergies, and that these allergies were often seasonal, peaking in the autumn, particularly after warm, humid summers. And other possible sources like animal dander or mold just didn't quite fit right with the seasonality of the allergy. But in the late 1960s, scientists in the Netherlands and Japan realized that the dust mite might be the culprit. They're found in large numbers in the dust that lines the unwashed and untouched corners of our homes. Their populations peaking in time with the runny noses and bleary eyes of dust allergies. But while experiments confirmed that mites really were the source of people's sensitivities to house dust, it wasn't clear what made them so special. So we'll get to that in a bit. James often finds dust mites in the humidity chambers he uses to keep his microbes alive. These chambers are made up of a dish lined with wet toilet paper, which is just about all a dust mite needs to feel right at home, especially when there's potentially some delicious microbes to munch on. So, to keep those other microbes from becoming a mite meal, James has to regularly clean out and disinfect the humidity chamber. Now, that cleaning might get rid of the dust mites in the humidity chamber, but the problem is that our houses are full of food for them because our houses are full of us. Of flakes from our skin that shed and gather all around and sustain the invisible mite. And this is a problem, not just because it means the mite can thrive in our homes, it's a problem because food means poop. Over the course of its life, a mite will produce about 1,000 pieces of poop that are roughly the size of a grain of pollen. Inside those bits of fecal matter are enzymes that help the dust mite eat its own poop and get nutrients that it might not have gotten the first time around. But should the dust mite choose to not revisit its prior meals, the feces will float around the room attached to other particles until eventually they settle down, perhaps on a pillow or on a pet's bed or a car seat. It's like we're living in a gigantic snow globe, except that the snow is dust mite feces. In 1981, researchers confirmed the bad news about this animal's poop. People are allergic to it. To be more specific, they confirmed that dust mite poop contains specific proteins that many people are allergic to. So if you're airing out some sheets and you start sneezing, what you might actually be reacting to is dust mite feces flying around the air. And we apologize for this image, but it is reality, and it has embedded in our heads, so we have to share it with you as well. But we can offer what might be a small comfort. There is another allergen from dust mites that has nothing to do with poop. Dust mites have a fairly lengthy mating process, sometimes taking up to 2 days to finish. This is a pretty lengthy time for any organism, but especially for an animal that's only got about 100 total days to live. Over the course of their life, the female dust mite will lay up to 80 eggs, which hatch into larvae that then go through several different stages of development before becoming adults. With each passing stage, the dust mite sheds its exoskeleton, leaving behind its youth, and that exoskeleton provides some other allergens for people to react to. But though that is something people are sometimes allergic to, it really is mostly just the poop that sets off people's allergies, so I guess there really wasn't that much comfort there after all. And even for a trained and cautious microbiologist, dust mites can become an unwelcome surprise. Once, James brought home some samples taken from a water dish that his neighbor left outside for their cat. The surface was covered in tiny round things, and James thought they might be rotifers. But when he looked at the surface of the scum under the microscope, there were no charming rotifers to be found. It was mites. Just hundreds of them crawling around the slide. It was so unpleasant that James immediately bleached the slide. Now, he's not sure if that sample is the reason, but for days after, James kept sneezing and having to deal with a runny nose, all of which pointed to a potential mite invasion. Fortunately, though, our homes are not a utopia for dust mites. What they really need is dark, which is why they prefer to dig themselves deep into carpets and other soft things that give them space to burrow. Dust mites have a harder time dealing with materials like suede that are difficult to hide themselves in, and they usually avoid hard surfaces that are exposed to light. So, for James, his weapons against the mite invasion were clear: a vacuum, a mattress cleaner, and a strong UV light bulb. It is one of the more ignoble ends to one of our organisms. We don't like to hurt them, unless they're hurting us. But I am sure that there is a dust mite somewhere in our homes right now, settling into a soft, dark abode of its own, with hardly a care in the world for the battle that was waged to bring you this video. If you have not abandoned this video yet to go clean your room, we do appreciate it. Because next up, we have water mites, who are perhaps less of a scourge to us than dust mites, but who are still capable of producing their own strange compounds with uncomfortable implications. For those of you afraid of spiders, the microcosmos probably seems like a safe haven. When you're scanning through a microscopic ocean full of single-celled organisms, the likelihood of a spider crawling across your screen feels comfortably low. The few times we've seen a spider under the microscope, it's because we put it there. But safe as the microcosmos might seem from a surprise spider attack, it would be misleading to pretend that it is completely free of spider-like sightings, because even at this small scale, you could still find yourself subject to an ambush of the arachnid sort. These are water mites, relatives of spiders in that they are also members of the arachnid class, and the resemblance is uncanny, especially with all of those 8 legs waving around. But that detail aside, there is something about this water mite that looks more like a cartoon spider, something you might have doodled in a notebook. For one, there's the eyes, those simple dots. Water mite species usually have 2 pairs, which mainly act to detect light. It's much less intimidating to stare into the eyes of the water mite than into the 8 eyes of a spider. Another reason for the cartoon spideriness of some water mites is down to a defining aspect of their shape. Spiders have segmented bodies with an abdomen that is distinct from the cephalothorax that holds its head, but water mites are not segmented. Instead, those different parts are fused together. In the case of this particular species, the final result is round and kind of adorable. So now we're going to disrupt that cuteness by bringing up a creature that we've talked about before, one that's more closely related to water mites and one that does not evoke any sense of cuteness. We're talking about dust mites, which are part of the same superorder of mites called Acariformes. If you haven't watched our episode about dust mites before, you should check it out after you watch this video, especially if you're looking for motivation to clean your room. Because, without spoiling too much, the main thing to know about dust mites is that their poop it's not great. I'm bringing that up now because while water mite poop might not evoke the same concern that dust mite poop does, it is still fascinating. Their excretory system is made up of a large tube connected to a pore. The tube takes in waste from the mite's version of blood called hemolymph, and in the tube the waste is stored as yellow or white crystals. To clear out its storage of crystals, the mite simply moves its muscles to push everything through its excretory pore. From the studies we've found on other mites with similar systems, our best guess is that these poops are guanine crystals produced by the mite's body as it breaks down nutrients. Now, crystal poop is weird, but the weirder thing is that crystalline poop is not the weirdest thing that water mites excrete. But before we get there, let's talk about just how red some of our water mites are. They're so red that they might seem like walking drops of blood. They are not actually chock full of blood, though. The red color is likely some kind of carotenoid that turns the water mite crimson. And for a time, scientists believed that the red color was a way for these species of water mites to flash a warning signal to fish, sort of a "do not eat me" expressed solely through a threatening hue. But, why? Why did scientists think fish would heed this warning anyway? Why would a fish bother to listen to a water mite when it could be eating the water mite instead? Well, many water mite species have an approach to warding off predators that is sticky. Water mites have little globe-shaped organs dotting their bodies called glandularia, each with a little opening and a little bristly hair called a seta. When something, say a fish, brushes up against that hair, it triggers the glandularia into releasing a milky fluid into the water, where it mixes into a tackier, more viscous substance. And for predators, the idea of having to wade through some gloppy mess to get to your food is probably unappealing. So, when the scientists saw, in the context of their own experiments, that fish seemed to quickly stop trying to eat water mites, they decided that the red coloring was water mites' way of telling fish we're the sticky prey. But while it's possible the fish do learn to not pick out these water mites for food, the idea that their red color exists specifically as a warning to predators does not hold up to the basics of how these particular species live. Red water mite species tend to be found in transient pools of water, places that fish don't often find themselves. So the likelihood that they would have evolved this trait for the purpose of warning fish is low. It's more likely that the pigments are a way of protecting them from ultraviolet light. It just maybe happened to also protect them from fish as well. And the sticky fluid that makes them unappealing to fish also has another use: reproduction. In one genus called Arenaris, the males use it to hold the females still during copulation. This is part of a wider spectrum of weird reproductive behaviors. On one end, there are the species like the ones we just mentioned, which engage very directly and physically with each other. On the other end of the spectrum, there are water mite species where the sexes don't feel the need to interact at all to make reproduction happen. They don't communicate, they don't touch. The males simply deposit spermatophores somewhere for the female counterparts to find them and pick them up. And then, somewhere between the directly copulating water mites and the cold shoulder water mites, there are the dancers. They're sort of like the second group in that males drop off their spermatophores, but they actually stick around, mostly so they can draw females in and help them find the spermatophores. And this is where the dancing comes in. Sometimes this involves vibrating their legs to mimic their favorite prey, drawing the attention and aggression of wandering females. Other times, though, this means waltzing together as a pair, moving in circles with careful pauses to pick up the spermatophores. We obviously don't have a video of that, or else we would be showing it to you, but at some point, some scientist watched that happen. Someone watched the dance of the mating water mites and they carefully documented it, just like someone saw the mitiverse fish and the crystal poops and the many other strange things that make up the lives of water mites. Before we dive into our next mite video, I want to take a moment to thank today's sponsor, Manacora Honey. Manacora is a family-owned business with a passion for producing the best quality Manuka honey in an ethical and sustainable way. Their rare single-origin honey is produced in New Zealand, where the bees only feed on the nectar of the Manuka tree, making honey that is rich, complex, and creamier than the honey you'll find at a supermarket. On top of that, Manacora honey is supercharged with unique antioxidants like leptospirin and prebiotics, and has 100 times more of a natural antibacterial compound called methylglyoxal, or MGO, than conventional honey. The 850 plus MGO honey has a creamy caramel texture that melts in your mouth and is great on toast, in your tea, or even drizzled over some ice cream. And if you're out on the go, running some extra errands or at the gym, be sure to check out their compostable honey sticks, perfect for that extra honey boost. If you head to manacora.com/microcosmos right now, you can get $25 off their starter kit, which comes with the MGO 850 Plus Manuka honey, a free travel pack of 5 honey sticks, a free wooden spoon, and also a free guidebook. It's a perfect gift for a loved one or just a sweet treat for yourself. That's manukora.com/microcosmos to get $25 off your starter kit. Okay, let's get back to the mites. So far, we've been describing the ways that mites make things that make other creatures uncomfortable. But to cast them solely as the excretion villains of the microcosmos would be unfair. In fact, if you're a fan of cheese, there's a good chance that you might actually be a fan of mites, too, even if you don't know it yet. In May of 2013, a shipment of around 1.5 tons of cheese was refused entry into the United States. The cheese in question was a spherical orange variety known as mimolette that's sometimes compared to cantaloupes in looks and lemons in taste. There's nothing super startling about that description, nothing to suggest at least that this is a suspicious cheese, but according to the Food and Drug Administration, this shipment of mimolette had a problem. It had mites. of mites on your cheese makes your skin crawl. We have good and bad news for you. The good news is that most cheeses are not usually filled with so many mites that the FDA decides to take action. The bad news? Well, this mite was scraped from the rind of a Milbenkäse, a cheese from Germany that is also known for its lemony flavor. And if you like Milbenkäse and Mimolette but hate mites, the bad news is you've been eating a lot of mites. The footage we're showing you today was sampled and recorded by Chloe Savar, one of our guest masters of microscopes. The last time we featured her videos, we were looking at the hidden structures behind our favorite fruits and vegetables. This time, she brought us cheese. Like right now, you are looking at the rind of a Milbenkäse. There's a rough sort of graininess to the texture, and you can imagine that it might feel bumpy beneath your fingers. But you also might notice that some of those bumps are moving. And that feeling under your fingertips is now probably a lot less pleasant to imagine. And that sensation might become worse when you imagine putting some of that cheese into your mouth, knowing that some of those mites will find their way into your body. Now, as gross as it is to imagine, and maybe it isn't, it's just eating animals, which lots of people do all the time, I cannot blame the mites. Cheese is delicious. Except that the mites aren't actually here because the cheese tastes good. It's really more the reverse. The cheese tastes good to us because the mites are there. Milbenkäse is the cheese that it is because of those mites. It begins as a low-fat curd cheese, kind of like cottage cheese mixed with salt and herbs, and then it is ripened in a wooden box. Inside of that box are cheese mites. More specifically, the species Tyrolychus casei. These mites feed on rye flour that is added to the box, producing digestive juices full of enzymes that help carry out the fermentation needed to develop the cheese. And after anywhere from a month to a year, you can eat the cheese, mites and all. It's estimated that there are around 2,000 mites in each square centimeter of the rind. Mimolette cheese is also made with the help of these mites, though the species and the processes are a little different. The mites of Mimolette eat the crust of the cheese and leave behind tiny holes that help the cheese breathe. The mite also excretes compounds that impact the ripening of the cheese, which is another not-so-pleasant image. Despite their differences, Milbenkäse and Mimolette both owe their flavor to the mites. Scientists have traced the lemony taste of the cheese directly to a compound called nerol, which is found in lemon oil and in cheese mite secretions. Remove the cheese mites from the process and you take away that flavor. In the case of Mimolette, though, the mites are brushed off of the cheese before shipment, and yet enough do remain that sometimes they can reproduce into a population that is large enough to alarm the FDA. According to news reports in 2013, the FDA didn't have an official limit on how many mites could be present on cheese, but ideally they wanted there to be no more than 1 mite per square centimeter. And the shipment that was making its way into the US had more mites than that, so the FDA stepped in. For us casual cheese eaters, that intervention might seem reasonable. Mites are pests. We see them again and again in the microcosmos, and they often turn up in places that we do not want them, and they cause various conditions that are not comfortable. And in some people who spend a long time working with these cheeses, mites can actually cause allergies. But for the people who love the cheese, the crackdown on Mimolette was not well received. This is a cheese that has been around for centuries without much issue. Plus, let's face it, cheese often includes some strange ingredients plucked straight from the invisible world of the microcosmos. Like, let's take a moment with this clip. Just looking at it, where do you think it came from? This is not a trick question or anything. If you saw the blue and you immediately thought blue cheese, well, you are correct. These samples were taken from the blue veins of the cheese, which are actually dug out by a fungus called a Penicillium roqueforti. These molds used to be found naturally in milk and cheese, and people would even take spores from the best cheese of the last batch and inoculate it on bread to use again. But today, spores are often added during the cheese-making process. As the fungus grows, it breaks down fats in the cheese and produces new flavors. The good news is that it is also safe for consumption.
as is cheese made with Geotrichum candidum, a fungus used in the production of a number of soft cheeses where it grows on the surface of the rind. In fact, it is so widely used in French cheese that one estimate suggested that a French person will eat around 8 kilograms of cheese containing Geotrichum candidum in just 1 year. Geotrichum candidum lives in a variety of habitats, including soil and grass, but also in raw milk, which is why it's often found in raw milk cheeses. And with enzymes that break down protein and fat, the fungus can shape the aroma and taste of the cheese overall. In some, it even leaves behind a velvety surface to the cheese. The overall effect of the fungus, though, depends on the strain of Geotrichum candidum. Some create what's known as peau de crapaud, or toad skin, and some are known to impart a greasy or bitter quality. And there are times when perhaps those traits are exactly what you want. In a way, it's like art made from the microcosmos, a careful adjustment to suit a person's taste. And maybe that is what made the response to the FDA's Mimolette blockage so strong. On the one hand, it's cheese. There are plenty of cheeses available at the store, and to those of us who are perhaps of less discerning taste, it seems like there should be plenty of alternatives should your favorite cheese be held up at the border. But art is art. Even if some of the artists are members of the microcosmos, they weave blue veins or construct velvety rinds or add hints of lemony brightness to the flavor. And through centuries of traditions, we have been the wielders and consumers of an art that they know purely as survival. And our own tastes, it seems, have won out. We haven't found a lot of information detailing the FDA's stance on Mimolette today, but we did find a 2015 post on a cheese blog that mentions seeing the cheese return to local stores. Which is good news for everyone, except maybe for the mites that find their way into your stomach.
Now, we have talked quite a bit about excretions today, including the most notable one of all, poop. But what is poop without a butt to produce it? Well, that is the question at the heart of our last video today, which is all about face mites. Yes, the mites that live on your face, because at the center of it all is a surprisingly important question. How many mite butts are on your face? A lot happened in the year 2022. Economies shifted, reigns ended, wars began. So it is okay if you missed out on this little bit of, we think, very important news. Demodex have buttholes. Now, perhaps you have never thought to wonder about this. Perhaps you have never even heard of a Demodex before, and you're just slowly putting together that it must be related to the creature that we are watching right now. Yeah, the one that looks like a tardigrade, but weirder, which says a lot given that tardigrades already look pretty weird to us. So you might wonder, why am I supposed to care if a Demodex has a butthole or not? Well, we care because they live on our faces. Demodex are a genus of tiny mites that build their lives around the hair follicles of various animals. And there are two species that are found on humans, Demodex folliculorum and Demodex brevis. They each have their own preferred nooks on our faces, with Demodex folliculorum preferring hair follicles and Demodex brevis preferring our subcutaneous glands. The mites we are looking at had the distinction of coming straight from the face of our master of microscopes, James, who saw a little black dot on his forehead and was curious what was going on inside. So he simply scraped the spot with the side of a microscope slide and took a look. But these mites don't always localize themselves in neat little dots, so sometimes scientists have to turn to other measures to study them. In one NPR interview, a scientist described applying glue to a microscope slide and then sticking it to a person's forehead, so as they peeled the slide off, the mites would peel off too. And look, we get it. Learning that there are little animals crawling around on your face, it might be a little unsettling. Even James, who spends just about every day thinking about microbes, found himself initially repulsed by what he found on his skin.
But then he realized that they look like tardigrades with big butts. And if we can all collectively love tardigrades the way that we seem to, perhaps we can find some space in our hearts for these little mites. They're even cute under the harsh glare of our UV light. The mites are tiny, less than 1 millimeter in length, and you can see two distinct halves to their body. At one end, the tardigrade end, as we like to call it in a purely unscientific way, are 8 stubby legs waving behind the Demodex's mouth. At the other end are their gastrointestinal organs and their genitals. Those spherical droplets in their body are oil droplets, the digested remains of the sebum and moisturizer that Demodex like to eat from our skin. Now, if at this moment your mind is conjuring up images of the Demodex wandering your face in search of oil to eat, you can rest easy. Well, for now at least. They're probably not wandering. They're just chilling out inside your pores. At night, though, Demodex do like to party. They emerge from your pores in search of each other, looking for other mites to mate with. And when they are done, they head back to your pores to lay their eggs. An adult Demodex folliculorum lays about 20 to 24 eggs in your hair follicles. Within 3 to 4 days, the young Demodex will hatch, emerging with only 6 legs, weirdly enough. As they develop into adulthood, the other 2 legs will develop as well. Their lifespan will end a few weeks later, at which point the dead mites will decompose in your follicles or sebaceous glands, turning the tiny pockets of your skin into little mite graveyards. It's a lot, I know. We keep trying to say that Demodex are cute, actually, but then we talk about little mite mating parties and mite graveyards on your skin, and none of that is cute. But here's the thing. We pretty much all have them. If you're watching this video, you probably have Demodex living on your face. And if you don't now, you will eventually. Now, they usually spread through physical contact, though a 2015 study found that we tend to primarily pass them on via close contact with our family members rather than strangers. And when they have found your face, they'll probably stick around, hiding in your pores and other spaces that make them hard to scrub out. Generally, that's fine. Demodex don't wreak much havoc on your skin. They can become too abundant, creating a distinctive white sheen that dermatologists call demodectic frost. That excess of mites is usually connected to a decline in the immune system, but these cases are very rare. For a time, there was a theory that Demodex could cause rosacea because they were thought to not have a butthole. What do those things have in common with each other? Well, the idea was that without an anus, the Demodex couldn't poop. Instead, the Demodex would spend their short lives accumulating waste in large cells in their body and storing it away. And when they died, the feces would burst from their bodies, releasing bacteria that could then cause rosacea. There are enough correlations between Demodex and the occurrence of rosacea to leave us considering that there could be a connection between the two, but we are here to vindicate the mites a little, because that mechanism is based on an idea that would turn out to be very wrong, the idea that Demodex don't have an anus. In 2022, scientists were studying the genes within Demodex, and among their results are some microscopy images and these words, which we hope will become a classic in the history of butthole science. There have been several reports that Demodex does not have an anus. And when Demodex dies, the accumulated waste spills into the pores of the skin and leads to inflammation. This is not correct. We've talked before about just how mysterious and confusing the history of anus evolution is. And so we were excited to hear this news. But the other results of the scientists' genetic study of the Demodex are also worth learning more about because they reveal just how strange our relationship with these creatures is. In particular, the scientists found that the Demodex are surprisingly simple, relying on a small number of proteins to survive. This likely drives their nocturnal behavior because they lack the compounds that allow their relatives to survive at all in the daytime. And this might be the result of just how lonely the Demodex mites are in an ecosystem built out of our skin where they face very few threats and very little competition. They're doing so well
that they may require less than they once did to survive. And that has been pushing them, at least according to these scientists, to a future where they might be symbionts with us, much like bacterial endosymbionts that have become fully embedded in their hosts. That is, for now, just a hypothesis. If there comes a day when the hypothesis is fulfilled, what do we do then? Do we consider them weird and creepy and maybe even a little rude? Or do we accept them as part of us, as inevitable as every other cell in our body? Or perhaps it is both, as nuanced as any other experience we have with our bodies, wonderful and terrible, all at once. Thank you for coming on this journey with us as we explore the unseen world that surrounds us. One thing that you gotta know as a Patreon patron of Journey to the Microcosmos is you don't know where the next episode is going, but you trust us to go in the direction that we want to go in, to discover what we can discover by not looking big but looking small. The people on the screen right now, they are our Patreon patrons, and they're the reason that we can do this. If you would like to join them, you can go to patreon.com/journeytomicro. If you want to see more from our master of microscopes, James Weiss, check out Jam and Germs on Instagram. And if you want to see more from us, there's always a subscribe button somewhere nearby.